Okay, if we look at number 40, it is maybe even a little bit easier because we don't have the angle. Let's read through it. The coefficient of kinetic friction between a 5 kilogram crate and a horizontal floor is 0.2. The crate is then pulled by a horizontal rope and starts to accelerate 2 meters per second squared. What would be the tension in the rope? Well, it's true we don't have an angle, but we do have acceleration, which is new. We didn't have that before. So again, let's start off with our free body diagram. We have gravity, of course. We have normal force, of course. We have this rope that is pulling, so we can say there's a force of tension from the rope going this way. And if the tension's going that way, then the frictional force is going this way. This time the friction is a kinetic friction because there's movement, there's acceleration. Let's see what's going on here. The sum of the forces in the y direction, of course, is 0, so we can calculate the normal force from that. So the y direction is the normal force and the force of gravity. We're solving for our normal force. Our gravitational force is mass times gravity. Our gravity is 50 kilograms and negative 9.8 meters per second squared. I'm going to get my calculator. And so our normal force is negative 490. Well, actually, it turns out to be positive 490 newtons, because it was negative over here, but then I added it to the other side. So now we have a positive 490 newtons for our normal force. Now we need that because when we talk on this side, we're going to talk about our frictional force, and frictional force depends on the normal force. So the sum of the forces in the x direction are the frictional force and the force of tension. So we're going to say that the frictional force plus the tension force, this time it's not stationary. If it's stationary, like up and down, it's 0. Or over here, this was a stationary object, and so they were 0. But in this case, it's not stationary, it is moving. And so if it's moving, we don't have a 0 over here. We have another mass times acceleration over here. So our formula now is the frictional force plus the tension force is equal to the mass times acceleration. Frictional force we know to be mu times the normal force. And the tension force, well, that's what we need to find. And the mass times acceleration, we can just leave that for now. Let's just leave it m times a. Okay, the mu. Do we know the mu? Yes, we do. It is 0.2. So we're going to go 0.2. And coefficients of friction do not have a unit on them. And then the normal force, we found that to be 490 newtons. We are solving for the tension. That's what the question is. What would the tension be in the rope? So on the other side, we have our mass of 50 kilograms, and we have the acceleration. The acceleration here is 2 meters per second squared. So again, we get out our calculator, we multiply these together, and that gives us 98 newtons plus the force of tension is equal to, we multiply these together, we get 100 newtons. The frictional force is acting to the left, the tension force is acting to the right. So the tension force is positive, but the frictional force is going to be negative. So now I need to add that 98 to the other side. And so when I add that to the other side, I get 198 newtons. So our force of tension is 198 newtons. And I believe that was the final question, right? They asked us what would the tension be. So there's our tension. To find that tension, we had to find the normal force. So we had to look in the y direction for the normal force because this depends on the normal force. And so that was part of the equation. So something that we just ran into up here is noted in this box here. And so what this is saying is when the acceleration is 0, so either it is constant velocity or it's not moving at all. So objects that are either at rest or moving with constant velocity are said to be in equilibrium. And so what's true about an object's acceleration if it's at equilibrium? Well, in that case, a equals 0. So complete the equations for an object in equilibrium. Well, that would be the sum of the forces in the x direction would be mass times the acceleration in the x direction. But if a is 0, 0 times anything is going to be 0. And for the y direction, same thing. We're going to talk about mass times acceleration in the y direction. But if acceleration is 0, then 0 times the mass is 0. So we use these equations, which we have been using frequently, whenever there is constant velocity or the object is at rest. Well, what if it's not? What if there is acceleration? Well, when there is acceleration, then we use just a slightly different equation. We say that the sum of the forces is equal to mass times acceleration. And this is just Newton's second law. It's just rewritten a little bit, but it's just still Newton's second law. And we would just say the sum of the forces is equal to mass times acceleration. And that's what I was doing over here. Up here, I used that, and we had not seen that before, so I just needed to clarify what we were doing. Okay, we have one last example, and then we're done. So we have an incline, and we have acceleration, both. So let's draw our incline. Okay, let's look at our free body diagram. Of course, we have the force of gravity. Of course, we have a normal force. Normal force is perpendicular. I tried my best to draw it perpendicular to the surface. We have the force of tension is pulling up the ramp, right? So it is going upward. So the force of tension is this way, and the force of friction is the opposite way. And there is a 30-degree angle here. Remember that the force of gravity is always like the hypotenuse, so that's how we're going to draw our vectors in there. So here's our free body diagram. I want to start, sometimes in physics problems, you might have a hard time getting started on some things. And so it's always good, for me at least, to just start with something I know, like at least something I know how to do so I can get in there, because these problems, as you know, can get pretty complicated. But I can always do the force of gravity. I feel like that's something that I have confidence in. I know how to find the force of gravity. So the force of gravity is mass times gravity. So that's going to be 205 times negative 9.8 meters per second squared. And when I multiply that out on my calculator, that comes out to be negative 2009. So the force of friction in the y direction and the force of friction in the x direction, I can also find those. I'm going to have to use my trigonometry to do it. This is a 30-degree angle. That's my theta. Theta is 30 in this case. So the force of gravity, I put an F, that should be a G. Force of gravity in the x direction, that is the opposite, that is sine. So it's going to be 2009 times the sine of 30. It's 2009 because that's the force of gravity, so that's that vector. That's the hypotenuse. So 2009 times the sine of 30, which comes out to be negative, or let's just call it, for now, let's just call it positive, 1004.5. We can figure out the sine when we go back and evaluate it. And then the force of gravity in the y direction is going to be 2009 times the cosine of theta, which is 30. So I'm going to go to my calculator and calculate that. And I get 1,739.85 newtons for this one. Talking about the sines. So it looks to me like that they're all going to be negative, aren't they? Because they're all going in the negative direction. So these are all going to be negative. Okay, so I have those. Those are the ones that I know. Now I want to go back and think about, because it is moving, I can't use equals to 0. Because it is moving, I have to say mass times acceleration. And for this, let's stick in the x direction. In the x direction, we have the frictional force in the x direction. And we have the force of tension in the x direction. And we have the force of gravity, the component, the x component of the gravity. That's also in there. It does not equal 0. It equals mass times acceleration. And then I'm running out of room over here. My mass is 205 kilograms. My acceleration is 0.8. That was from this right here, 0.8 meters per second squared. Okay, my mu is 0.9. And my normal force is equivalent to the force of gravity in the y direction. The normal force is positive, 1739.85. Okay, and then tension is what I'm looking for, and this is still negative. So let's just kind of go back and make sure. Force of gravity in the x direction is going to the left, so that is negative. This first number is the frictional force. It should also be negative because it's going to the left as well. The force of tension is positive because it's going to the right. Okay, so now if I get out my calculator and I multiply some of these numbers and add them together. So I multiplied that and I added it to 1004 and I got 2,570.4 newtons plus the force of tension is 164. So in other words, I need to add that 2,570 newtons to the other side. And so when I add that over, I get 2,734.36 newtons. Okay, a lot of examples in this video. This part of the calculations, of course, is definitely part of physics, understanding how all these numbers are going to work together. We will work some more on problems in class.